Hello and welcome to another video from the team at Dodgy Software. Today I'm going to feature custom materials. Materials can be found when you go to the Window menu, then you go down to Rendering Editors and you go to Hypershade. And what you're presented with is a huge list of materials and all material components and the ability to build them all up in nodes. Today we're going to actually create a custom one. So let's go through and let's swap windows and go and take a look at some of the code behind a custom material. This is the main method, which is the entry level for a project which creates a DLL. In order to use it with Maya successfully, you need to rename the DLL to MLL, which is a Maya link library. There are a number of components because the material is a little bit more complicated than other plugins. For this one, we have to use a script in order to build the internal attributes. Well, not so much the internal attributes to the actual material, but to the ones that are accessible in the interface. So if I show you, that means that if I create a box here and then I go over and select the Lambert tab, you can see that there's color, transparency, ambient color, incandescence, and there's text boxes there that cover different properties. What we're going to be doing is, I guess, creating sort of either Phong / blend shader material by default. And I'll just briefly cover what this script file does. So the callback is a global procedure. We call this AEDS material template. It can be a little confusing because the way that Maya works internally is when you specify DS material, it adds the AE and it adds the template like to the file name. And it automatically will pick up this script file, which is I found particularly confusing when I first started. Okay, so what we have is we're going to use the scroll layout, which is the same one that the same layout style that all the default materials use, and this is where part of the magic happens. This is where we start off with adding controls to a nice new collapsible pane in our scroll layout. And we're going to add ambient color, diffuse color, specular color, emissive color, and shininess. These properties are attributes that come from the material node. So if you add these and there's nothing that they're connected to, then your material will just simply crash. Now, what we have here is this is almost boilerplate code, in fact, as we hide the internal node attributes. Now, that does is that will stop them showing up in the attribute pane when you go to try and edit a material. Anyway, back to main.cpp. So there are two functions you have to use in order to get your Maya DLL to register. That is the initialize plugin and the uninitialized plugin. What you then do is you need to register the plugin specifying a number of information. The first is the plugin name. In this case it's going to be DS material, and then there is an ID for this plugin, a creator function which is a static member function to the DS material class, an initialize function which sets up the initial and default properties of the material, and then we specify the type of plugin that this is. In this case, this one is a hardware shader node, and then we specify the location that the plugin can be found. Now, the location that I've got here is shader /surface/utility. So what we'll do is later on in the video you'll see that our shader inside the hypershade renderer is located there. To uninitialize, or rather to deregister our plugin, we call the plugin.deregister node, and then we pass to it the ID of the plugin that we created. Now let's go take a look at the material class. The DSMaterial class implements the MPxHwMaterial node. Now what I have is a large cluster of functions here which have to be implemented in order to get it working. There are a couple of different sets of functions which need to be implemented. The first being just bind, geometry, and unbind. Those are for the software shading components. So when you go to render your scene and you can choose either software or hardware, these are the functions that you implement to control the software shading. Now the hardware shading is always OpenGL, so we've got functions here for GL-bind, GL-geometry, and GL-unbind. Now there are a number of other functions here that aren't necessarily worth explaining, but probably the most important that are worthy of mention are this cluster here, the static objects. These are the internal attributes for your shader. This is how your shader is able to communicate with the Mel script and with Maya. Okay, now let's jump into the CPP file and take a look. So here I'm specifying the ID of this plugin. In the creator function, I'm returning a new instance of the DSMaterial class. The DSMaterial class implements the MPxHwMaterial node. In my initialize method, this is where I am adding to the DSMaterial class all of the properties that make up this material. Now these are global properties that work with the Mel interface, and they sort of allow us to specify the data types and all of the relevant information that allows Maya to determine what types of boxes to add. So for instance, if we take another look at the DSMaterial template, where we're adding the controls, it doesn't specify what type of control to add. That's where this section of code comes in. So if you notice where we've got say an MFN numeric attribute up here, what we're able to do is we call the create method there, and then we assign it a name, we assign it a data type. In this case it is a K float, and we have a status as to whether it returns true or not. We have a couple of functions here, just global macros that check to see if the status is correct, to make sure that it was created. In the event that you've already got an existing one and you try and create another one by the same name, then the status will be a failure on that one. Now these three create individual floats which make up a color. So here I've taken ambient red, ambient green, ambient blue, and I've joined them together here with the create method. So I've given this one a name, and then I've joined three components together, and because this one is set up to be a color, you'll notice I'm able to set the default color to be 0.25, 0.25, 0.25. And this one here is the function which is the most magical. This one is at the add attribute ambient color. This adds the attribute to this object. So this creates smaller components which we then use. We concatenate them together to make an attribute called ambient color, which is over here in our script where we've got the edited template add control ambient color. That's where that name comes from. So see how we've got that there. If we don't add this attribute here, the script won't be able to find that variable, and that's the end. So that's how we create a number of individual components, and we combine them together to form an RGB color, or RGB rather. Now you see we've replicated that code there for the diffuse color, for the specular color, each time taking careful attention to add the attribute to the node. We've done the same again for our emissive color. And finally we have shininess. Shininess is just a simple k-float. We set its default value to 2, and then we add the attribute there. Now that ensures that our Mel script can now pick up all of those attributes, since it adds these attributes to the nodes when we're going through. For instance, let me show you. I'll go back to the Maya window and we'll go to Rendering Editor and Hypershade. The attributes are what allow us to connect different parts together. So if I click on the Lambert node and I click on Graph Network, and then say I grab the checker, I create a checker material here. What the nodes are is, if I try and connect these two together, each one of these is an attribute associated with the material. So where I've got ambient color, color, incandescent, transparency, and I'll demonstrate that when we load our plugin in later. Those are your attributes that are associated with the node. Okay, let's go back to Visual Studio and continue. Now the compute method is absolutely critical, because what will happen is the compute method is called on each node attached to the DAG tree on an update. So the Maya window does not update anything up until you make a change. So if I scroll inward or outward, that causes Maya to go through the entire DAG tree one by one, calling the compute method on all of the objects there. So if you get this section of code wrong, then nothing good will happen. So in this case, I specify the color of the default swatch. So I factor in the ambient, the diffuse, and specular, and emissive color, and I do absolutely nothing with it. Mainly because I've seen some plugins that will go through and pretty much apply a Phong shader and render that to a texture every single time you try to change a property in it. And because this was just a very basic template program, I really did not want to go to that much trouble for it. The post constructor here is called after the constructor and simply sets the default values for ambient, diffuse, specular, emissive, and shininess. And these are, instead of them being the global attributes associated with the plugin instance, these are the local variables that apply specifically to this instance of the material, rather than the attributes of the plugin itself. Now this is what we're doing in the bind method. Because this in the software shader we're using OpenGL again. We're pushing all of the attributes. That way we store them later on down here in the unbind method, where we pop them again and return success. We enable the color material, we enable lighting, then we set the color materials for ambient, diffuse, specular, and emissive colors. We also set the shininess of the material, because OpenGL by default uses, or at least the fixed pipeline, uses a Blinn shader algorithm. Now we do the exact same down here for GL bind, GL geometry, and for GL unbind. And that is the totality of the code required to create your own custom material. There's obviously a lot more to it, a lot trickier things, and this video represents my understanding of it at the time of creation. If there has been anything in the video that I'm incorrect about, I would like to learn more, but there is an extreme drought of information about how to do a lot of these things. So, alright, let's import, let's try and get the plugin working inside of Maya. So we go to Windows, Settings and Preferences, Plugin Manager, and then we scroll down to find, in this case, the dsMaterial.mml. Then we go up to Window, Rendering Editors, Hypershade, and there's our material, dsMaterial. So let's create a new instance of one. We'll click on that object, assign the material to selection, and there we go. Now just to elaborate, just to show what happens with those attributes that we added, there's our checker pattern. I'll try and drag that over here. Now do you see how when we added those materials we had ambient color, diffuse color, emissive color, specular color? For some reason Shininess isn't showing up there, probably because you can't use a texture to determine shininess, probably because it's a float, whereas that's I guess that's an internal working of the Maya API. But anyway, let me delete those nodes from the scene, and let's click on the material here. Hope it comes up. Yep, there we go. And let's begin tweaking some of the properties. Now, if you remember, the mel script was responsible for generating this common material attribute, for setting the layout, and for connecting each one of these to the attributes in the node. Now, let's go through and change some settings here. I want to keep the specular color white. Let's get rid of the ambient color entirely. And if we change the diffuse color, see how we can change the color, or change the intensity. Let's go through and begin tinkering with some colors. Now we've got a green one, a blue one, should be a dark blue. Let's have a look here. It's because the specular color is a little high. Now what I will do at this point is let's delete that object and let's create a sphere instead, just so that we can see the specular highlight. Window, Rendering Editor, Hypershade, and let's assign to selection. There we go. Okay, so we go to dsMaterial here. Let's increase the specularity to 200. So that gives us a singular point. Let's orbit around it to be able to see the specular highlight moving around. I'll increase the size of the specular highlight here by decreasing that. And let's do it again. And let's change the color from blue to grey. We'll create a very blunt, not very shiny object now by setting the shininess back to 2. Okay, that concludes the demonstration of a custom material for Autodesk Maya, the basics of what the code looks like behind it. Until next time, take care.